This is question 2 on the assignment. The jet was meant to be vertically aligned, so just ignore the fact that this got copied a little wrong. And it says that we can assume that the magnitude of the velocity of the air remains constant. That's a good one. That basically says we can neglect the elevation effects on the flow. So if it's coming in here at 30 meters per second, it goes out there at 30 meters per second, but with the angle changed. And we'll make the assumption that it actually goes off straight at the angles of the cone. So the outlet velocity and the inlet velocity are both the same magnitude, but the outlet vertical component of velocity is smaller. And it's a cosine of 30 degrees effect. It's going this way, so the vertical component is only cos 30 of the total velocity. So we get this factor 0.866 for the cosine of 30 degrees. Some of the forces acting on the control volume in the y direction, if we draw our control volume just outside the whole package here, then that'll be equal to the mass flow rate out times the v component of velocity, the vertical component of velocity out, minus the mass flow rate in times the vertical component of velocity in. So this is bigger than that because the velocity in the vertical direction is bigger here than it is here. Now the forces that are acting on this volume, there's this Fa up here, which is acting downwards, so negative Fa is one of the forces acting on the volume, plus whatever the weight of that cone is also acting downwards. So that'll be a negative sign, negative W again. Mass flow rate, it's the same going out as it was coming in. It's easier to calculate down here where it was coming in. Density times the velocity in times the area in gives us the volume flow rate times the density gives us the mass flow rate in. And that's the same as the mass flow rate out for steady flow. The outbound velocity component in the vertical direction, 0.866 times V in, minus, and in this case it's just V in, is what it came in with at the bottom. Rearranging this for W, we put the areas in and put the numbers in, and we wind up with 1.036 newtons is the force of the weight of that cone acting downwards. Now that's got to divide by G to get that as in terms of the mass. That'll be W divided by G, and that gives an answer of 0.106 kilograms for the mass of this cone. So that gets us the answer that we were looking for.